Hi, today we're going to be looking at some Skew boreholes, and this question is just an introductory question to the topic. It's actually the first question in David Anderson's book. So if we look here, that we have a contour map. A and B are points whose altitudes are 80 meters and 100 meters. B is located 80 meters east of A. So I've got a line here at the bottom. Point A is here, and point B is over here, and that line between them would be 80 meters in the eastern direction. So if we look at the Skew borehole A, it's drilled in a southerly direction in plan and has an actual inclination of 45 degrees to the horizontal plane. So that means it will be coming straight down. It'll be stopping somewhere around this direction. We don't know where yet. And B is drilled in the northwesterly direction in plan and has an actual inclination of 65 degrees to the horizontal plane. So we know that B over here will be going somewhere in this direction. It'll stop somewhere along that line, but we don't know where yet. So if I turn on our layers, it'll actually show us the completed plan and elevation of A and B. So there we have it. But and like I said, B goes in the northwest direction, stops some out here, and A down here. But how have we gotten where these have stopped in the plan and also in elevation for B? Well, in the elevation we know the heights because for A it'll be straight up from A and 80 meters high. For B it will be straight up from point B and 100 meters high. For A it's easy to find the point because it's going in a southerly direction, it'll just be a straight line. For B, not so simple. So to get all these points, we use our angles of inclination that are given to us in the question. So if I turn on this layer here, it actually shows the completed construction of finding all these. So for A, we've found where A finishes in plan by using our angle of inclination from the top to where it intersects our XY line, drop down and rotate around, and where it intersects our southerly line, we find our Skew borehole A in plan. In B, we find where it finishes by using our angle of inclination again, dropping it down, rotating it around where it intersects our northwest line, and project it back up to elevation, and we are given our two Skew boreholes. We just have to draw them in. So what is the next part of the question? For the next part of the question, we need to use the top and bottom surfaces of our stratum, which are given to us here. So say for example, A, we have stratum with top and bottom surfaces of altitudes of 65 meters and 25 meters. So if you notice A over here, I've got altitudes of 25 and 65 marked out, and I have them in plan. But how do I get them, I have them in elevation, but how do I find these in plan? Because obviously if I'm looking straight down at them, I won't know where they are. Very simple, I use my angle of inclination that I was drawing earlier. So I project them across, I project them down, and I rotate them around, and that gives me those points in plan. It's much easier in plan and elevation for the Skew borehole B. We are given altitudes of 80 meters and 45 meters for the head wall and foot wall here, and these are simply marked out 80, 45, and then projected down to plan, and they will be right there for that. So once these are joined up, we can draw them in, and that will give us our head wall and our foot wall. So once we have our head wall and our foot wall, what must we do next? Next, we are now in a position where we can start solving our problem. So the real task behind this Skew borehole question is finding our strip, our strike, our dip, and our thickness of our stratum. So we've got the head wall and the foot wall of the stratum here. So what we need to do is find the strike, dip, and thickness of this stratum. So to start off this process, what we need to do is find our strike. So a strike for us will be a horizontal cutting plane across any of these 4 points. So for this example, I've chosen the head wall in A, and that's the strike here, going straight across. So you might ask yourself, how might we have found this point here, and where has this line come from? This line was brought from the head wall in B and is parallel with our foot wall in AB as well. And where that intersects our strike in elevation gives us this point. This point is then projected down to plan, where a parallel line from the head wall in B is going to intersect it again. This line is parallel with the foot wall of the stratum in plan. Giving us this point of intersection will give us our strike, which we can bring from the head wall in A again. So now we can begin to find our thickness and our stratum. So as you can see, we've brought our strike out here from the head wall in A. Now what we need to do is use our x1, y1, which will be perpendicular to that strike, giving us an auxiliary view into the stratum. This will help us find our thickness and our dip of the stratum. So once we've got this, we can simply use our auxiliary method of going 2 views back, taking our heights from our elevation and placing them in our x1, y1, and that way we can use these points, join them up, and get the thickness. So if I just simply turn on the next layer, you can see our thickness is in there now, and these points are actually taken straight from the elevation. So for the AF here, I've taken this height from here to here, straight from plan. Those will be the same height. And the same goes for the rest of the points. So that's our thickness there. So we've now got our strike, which is this line out here. We've got our thickness, but our dip. How do we get our dip? So our dip is simply just a line which is the angle, which is between the thickness and the x1, y1 here. So to simplify this, I'm going to bring our x1, y1 a lot closer. I'm just going to bring it up to this point here. I want to turn it on there. So you can see our dip now is actually much easier to read. It's actually between these two lines here. So this is the dip, and our dip angle then, if I was to go in smart dimension that, just for the sake of proof, our dip angle is actually 7.52 degrees. So there we have it. That's strike, dip, and thickness of the stratum got. Thank you for watching, and goodbye.